Hello. Uh, Now here's an example. We're not going to actually do the whole chi-square test this time, but an example of when you would use it. So here are the number of accidents per day, Monday through Sunday, and taken from a random sample. And we want to check to see if these accidents are evenly spread throughout the week. So what we could do is we could do a one proportion z-test for each of these values. But it's not very efficient. That means you're going to do 7 tests, and the more tests you do, the more likely you'll have type 1 errors. So we need another method for solving for this table. This is a one-way table with 7 cells. So what we do is what we call a goodness of fit test. A goodness of fit test is used to help determine whether a population has a certain hypothesized distribution, expressed by the proportion of the individuals in the population. Uh, so our null hypothesis looks a little bit different with chi-squares. We actually write words. Our null hypothesis is the actual population proportion are equal to the hypothesized proportion. Now, I was a little bit, when I said you actually write words, you can do this without writing words. And if you do this without writing words, what you would write is proportion of Monday equals proportion of Tuesday equals proportion of Wednesday equals and so on. But when you write it this way, you have to define all of those parameters, which makes it a little bit difficult, or just a longer process. So you can do it this way, but I prefer to just write this, and you get the same point across. Now what we end up finding is we want to find an x squared, which estimates our chi-squared. To find our x squared, we take each observed count minus what we would expect to be in that situation and square it, all divided by our expected count. Now that x squared, like I said, has approximately chi-square distribution. That's like an x, just has some curlies on it, with a k minus 1 degree of freedom. Uh, Now our alternative hypothesis is at least 2, or you can just say at least 1 of the actual population proportions differ from the hypothesized proportions. The p-value is the probability that your chi-squared is greater than your x squared. Uh, this will make sense in a bit. And then we want to look at the conditions. One condition is that it's an SRS. Another is that we have to check to see that your test has no more than 20% of the values less than 5. This makes the conditions really easy. So as long as all the expected values are greater than 5, we just check the SRS and check this, and we're good to go with our distribution. So here's how we can figure this out. Now, instead, uh, if we wanted to figure out what we would expect to be in each of these columns, these are 7 days of the week, and they total up to 699. And so if I divided 699 by 7, I would get 99.85. So let's say 99.85, let's say 99.9. So that's what we would expect each of these to be if the proportions were equal. So if people got in accidents the same amount each day. Now, if I want to find my observed minus expected squared over expected, I would take 20 minus my expected, square it over my expected, which is 99.9. Then I would do that 133 minus 99, square it over 99, 126 minus 99.9, square it over 99.9, and you so on and so on all the way down. So each of these values will have a chi-square statistic. Now I just went through the calculations on my calculator, and I found this to be 63.863. This for Tuesday to be 11. The next one to be 6.844. The next one to be 35.029. Friday is 13.082. Saturday is 1.729, or so 3, and then Sunday it's 77.3. Now these are our x squared values. And so the values that are closest to 0, those are the ones that are closest to our expected value. If our chi-square is highest, that means there's the biggest difference between our actual value and what we would expect if they were evenly distributed throughout the week. All right, now when we sum up our chi-squared number, we just have to add up that whole column. So if I take the sum, I get 208.85. That's my x squared value. Now in the next video, I'm going to do a significance test with this. So then I'll tell you how to get p-value and such.